On to question 2 from the Cambridge International A-Level Computer Science Paper 4 from the Winter 2022 series. A computer game is being developed. The game has 10 different characters that are all active in the game. Part of the game is being written using object-oriented programming. How weird. So some of the game's using OOP and some of the game isn't. The class character stores data about the characters. Each character has a name and the X coordinate and Y coordinate. Okay, there have been many questions like this. I'm sure this shouldn't be too challenging. So let's create a new file called question2.py. I'm pretty sure that this question at some point is going to ask us to read the lines of data from the external file that they give us. We're probably going to need to load names and character points or something into the file. So if you do enough of these past papers, you should see that this kind of question has come up several times before. We need to create a class for character, and we need to create its constructor. And what do we need to do for character's constructor? We need to initialize them to parameters. So name is coming in as a string, and X coordinate is coming in as an integer, and a Y coordinate is coming in as an integer. And we then need to create some private properties for each of those parameters. So self.name comes from name, self.x coordinate is coming from the parameter x coordinate, self.y coordinate is coming from the parameter y coordinate. So let's add in some pseudocode comments to show that we understand that these are private properties. Why do we use private? Just a bit of paper 3 revision. So using private properties prevents data from being changed outside of the scope of the object or accessed from outside of the scope of the object. Why do we do this? This is for encapsulation. So one of the kind of OOP programming principles, keep everything where it belongs, don't mix things up. So that's the constructor, and we don't need to write any other methods, and we've done some declarations using comments. Let's just perhaps test that our code runs. And I've done something wrong because I've messed up my brackets because I can't see my code. Let's not have a bracket there. Let's try that again. Okay, so it compiles, or it passes the syntax checks. So let's paste that in. Oops. Something we might do here to make it kind of look a bit neater is I might change it so the comments are above instead. And now that we've changed VS Code into light mode, I suppose we could just paste the code in as text with the formatting and keep the formatting. Let's add this comment in just to remind you, or let's leave this comment in just to remind you that in Python, when they're talking about a method called constructor, in Python, that's dunder, init, dunder. All right, let's go on to the next question. So now we need to write the getters. What do getters do? Well, when you have encapsulation, you have private properties. You need get methods to be able to extract get the data out of the objects, basically. We always need self, what defines a method. Well, you'll always see self in Python if it's a function or a procedure inside an object. Let's return the value of the name property. Let's add a little type hint to show that this function returns a string. Let's do the same for x coordinate. However, for x coordinate, oh, it's just called getX. However, for get x coordinate, it's going to be an integer. Let's do the same for the y coordinate. So writing these methods allows us to extract or get the properties from outside. write program code for 3 get methods with the class character. We've done that. So that will be our evidence again. Let's just do a check to make sure that it's still compiling. Okay, it's fine. Put that in. Let's now do part 2C. Now we need to write change position. And I'm pretty sure what's going to happen here is we're going to have a new x or x change. So coming into the method is a value x change, which is an integer, and also a value y change, which is an integer. And what's going to happen is we're going to use these parameters to modify the value stored inside the class for x coordinate. And do the same for y. All right, so that should be our evidence for the next question. Oops, let's just check it. Okay, it works. So the exchange parameter comes in, and we increment what is stored inside the property by this new value. The same goes for y. Okay, the main program has a 1D array of characters. So let's say if name is main, this is our main program in Python. And what we need to do is create a 1D array of characters. So declare characters, which is an array from 0 to 9, because there are 10 characters of character. So let's create our array. So characters equals, I'm just going to use null values, because obviously when we're declaring an array in Python, Python doesn't support arrays. We're not going to be able to instantiate characters without knowing name x and y coordinates. So that's why we will need to do this like this. That's the equivalent of declaring an array of objects in Python when we need instantiation parameters. You could also use a list. As they say at the top, they could say you could start with an empty list, you could use append, but let's try and match what they're saying with arrays. The game has a maximum of 10 characters. The character names, x coordinates and y coordinates are stored in a file. Let's open the file. The file is called characters.txt as file. And we need to go through and get the name and the x and the y. And we need to set characters. So we need to read all of the characters, store each character as an object. So yeah, what do we need to do? We need to perhaps use read line here. So we know that there are 10 characters. So we can say for index in range 0 to 10. We want to count 10 times. Or let's call it count maybe. This is an integer, by the way. We need to get the file, and we need to read a line from the file. Let's just make sure we strip it as well. And the first time we do that, that is going to give us the name. And the second time we do that, that is going to give us the x position. And the third time we do that, that is going to give us the y position. We just need to make sure that with x and y, these are integer values. So let's cast them into integers as well. And then we want to create a character. So we're going to instantiate a character and pass in name, x, and y. So let's pass in the name, let's pass in the x position, let's pass in the y position. And then what we need to do is we need to put that in our array. So maybe I do want that to be called index, because we're now actually going to use that variable as an index. Characters at index now stores a separate character object at the position. And I think that should be it. Let's just say there's nothing I'm missing, is there? Again, let's just check that it still compiles, and we've got a problem because I've spelt the file name wrong. Let's try again. Okay, it compiles. That should be the evidence for question D. It's probably better to not make your answers split across different pages like that, by the way. So maybe just make it neat. You can even say something like C over leaf when it gets printed. I don't want any confusion, so try to make it as clear as possible. Needs to read the main program needs to. We were meant to do this all in the main program. Correct. The main program needs to read in a character's name from the user. Username equals input. What is the character's name? Oh, let's try. Enter character to search for, and string. Let's just add my comments here. That's a string. That's an integer. That's an integer. We need to go through the array until we find basically a linear search. So it repeats until the user enters a name that exists in the array. So let's make a Boolean flag, found equals false, and we can say while not found. While we haven't found something, let's get a thing from the character, and you might be tempted here to just say if search character in something something something, but we're not allowed to do that in Python. They want you to do a linear search. So let's say while not found and index less than 10, index equal to the first one, that's an integer. What we want to say like is if in the characters index, if in the characters array at this current index, we need to be able to get the name out of the character, because if we try to use the private property, we won't be able to access it. So we need to call get name. If the character at this index name equals the one that's being searched for, then we can set found to true, and we can probably print something like character found at index index. Otherwise, index should go up by 1. Let's have a go at testing it and see. So let's put in Bob. I should reject it because there's no character called Bob. Let's put in a character that's actually there. So let's try Kane. And we found Kane at index 8. So let's put that in as our evidence for 2E. Let's read what's required for 2F. The user will enter a letter to identify the direction the chosen character from part 2E should move. If A is input, the character moves left. If W is input, the character moves up, etc., etc. So take a letter until it is valid. This is also the main program. So again, let's say valid equals false, which is a Boolean, while not valid. Chosen direction equals input. What direction? A, W, S, or D? And then we want to say like if chosen direction until it is a valid move. In this case, I think it's probably fine to use the in, because we've already shown evidence that we know how to do a linear search. So I think it's probably fine here to say, to just use the Python in operator. If chosen direction in valid equals true, else print not valid. Oh, we might want to say something here. If not found, character was not found. Let's just add a nice message to make it clearer when we've exited the inner loop and the character has not been found. Let's print a message. Let's just update the answer for that. So what we need to do is change the position of the character with the valid direction. So okay, so if they chose the direction A, this means that the character that we chose, which was this one, characters at index dot what's the name of the method? Change position. And if it's A, then we need to move left. So the X coordinate changes by -1 and the Y coordinate changes by 0. What are the other branches that we need? If W is chosen instead, then that needs to be up. So the Y coordinate needs to go up by 1. S is down, so the Y coordinate needs to go down by 1. And D is right, so the X coordinate needs to go up by 1. That should be okay. Again, let's just check that it compiles. And I've got some strange quote mark somewhere. Let's search for Qui this time. Let's see D, and it runs. That should be fine. So that's the evidence for F. How many marks is that? 7 marks. A reasonable number of marks for that. When a change to the character's position is made, the program needs to output the character's name and the new X and Y coordinates of the character in the format. Amend the main program. So you might be tempted to do this inside the scope of the change position method, but that would not get you the mark because they're telling you to amend the main program. So what we need to do is put in a print statement to say the character's name has changed coordinates to, and then the new X and the new Y position. So they're seeing if you understand encapsulation, do you understand how to use the get methods, etc. So we can actually we don't need the get method here because we've got search character, stores the name of the character, has changed coordinates to X equals, let's use an F string for this, X equals something and Y equals something. And the something will be, well, let's make a variable called xpos, let's make one called ypos. And let's say, okay, how do we know xpos? Well, we say in the character, we need to run the getX method. And then the same for the ypos. We need to run the getY method. And that will give us the new xpos and ypos values. That's an integer. That's an integer. Will that work? And let's just check that. Whoops. Let's check that. Let's check that. Compiles. So test your program by inputting. Let's put that in as our evidence. So that's for G1. Let's do the final task, which is G2. Let's search for Thomas. It's not found. Let's search for Chi. Not found. Interesting. So what are they expecting you to do here? Because Chi is the name of a character, you actually need to put in a bit of validation to make sure that Chi can be found. So let's just add something into the code here. We need to make sure that when we add Chi, we need to compare the characters so they're case insensitive. So let's just update our answers. So again, there's a kind of hidden requirement there. Doesn't say anything about converting them to lowercase, but it's like a bit of a hidden requirement. So let's just update our answer for the linear search question. How's that messing up the formatting? All right, let's try that again to see if it works. So search for Thomas. Thomas is not found. Search for Chi. I'm not sure how to say this name. Characters found. Put in X. X is not valid. Put in A, and then we get an error. So can you spot the mistake I'm saying? I'm seeing type object is not subscriptable. What mistake have I made with that? So it's saying that I'm trying to subscript into a type. What is a type? So a class is a type. Can you see I've used the name character, which is a type, instead of the name of an array. You can subscript to arrays, but you can't subscript to types. And what's the name of the array? The array was characters. Again, so Thomas is not found. Chi, we can't do X, A, and Chi has changed coordinates to 83 and Y equals 9. Should that be correct? Yes, he was already on 9, so I don't see why. That's quite confusing. Why have they written 0 there? Should move. So because the character starts at position 84, 9, if you move him left once, then the new position will be 83, 9. I'm guessing they've made a mistake there, or I guess that's just one example. They're not expecting that to be the output, but yeah, don't be tricked by that. So that's it. Let's take a screenshot and let's put that one in. That was the evidence for the final question, or the final part of question 2.